Hello, everybody. Thanks for being here. We're very excited to have Flow Blockchain, a native blockchain from Dapper Labs, the team behind CryptoKitties, and also very excited to have with me Sebastien La Duca, president of CMU Blockchain Group. This is our event number 16 of this series of virtual events we'll be running with BAF. If you've been with us since the first event, kudos to you and thanks for sticking around. If you're new, you'll probably wonder what we are. So I'm going to give you a little bit of background of what we do and who we are, and then I'll give the stage to Alex and Sebastien. In short, the Blockchain Acceleration Foundation is a 501c3 nonprofit based in California and composed by different blockchain clubs around California. As we entered this new virtual world, we kind of expanded all across the United States because now it's easier to connect, believe it or not. So very excited to connect with such great clubs like CMU, but other clubs on the East Coast as well. Our goal is to accelerate blockchain education, believe it or not. We do so by organizing these events, but also by starting accredited blockchain courses at universities. We are actually just launched our new and fourth course at UC Davis. We're very excited about that. But to keep it short, I think that's plenty of background about us. I'm going to drop some links in the chat. If you want to follow us, find out what we do, or become a free BAF member, fill out our membership application to stay in touch with us and check all our initiatives and upcoming programs. And with that said, Sebastien, Alex, I leave it up to you.
Well, hello, everyone. Thank you guys all for coming today. And I'd like to start by learning a little bit about Flow, maybe get a little bit of an introduction. So, Alex, can you introduce yourself to us?
Hi, I'm Alex. So I'm the lead engineer, lead architect of the Flow, protocol team. I've been involved with Flow since about 2018, May, where we started thinking about what it would take to build a scalable blockchain, or what we were looking for in a scalable blockchain. And so my background is mainly applied mathematics, and as you all know, blockchains are pretty reliant on good mathematics. So I guess that's how I became affiliated, or started working on Flow on the research project initially. My background from like 10 years ago is quantum physics and mathematics and computer science. I worked many years in applied data science and machine learning. And then since about 2.5 years, I'm working on Flow.
Awesome, thank you. So hi everyone. You might not have met me before. My name is Sebastien. I'm a senior at Carnegie Mellon, and I'm the president of Carnegie Mellon's Blockchain Club. I actually got into blockchain maybe 8 months or so, basically when the pandemic was kind of taking over the world and destroying world institutions. I was kind of sitting alone in my room, realizing I should be doing something better with the code that I write. And so I fundamentally believe this technology is going to be really important in the next 100, 150, 200, possibly more years of humanity. And I'm really interested in learning how we can make it work. So that being said, can you tell us a little bit about why Flow exists, right? There's so many blockchains, right? Like we had stuff before Bitcoin, but we had Bitcoin, we had Ethereum, we had, and now we have all of these proof of stake chains. We have Zilliqa, we have Cosmos, we now have Polkadot. Just tell us a little bit about why Flow, and what led you guys to start building another one.
Thank you, Bastian. That's a pretty interesting story. So it all began in around 2017, October. So when we initially built CryptoKitties, like the blockchain game which runs on Ethereum, where you can collect virtual kitties, you can breed them. We largely did that project initially as just a technology evaluation project, and then suddenly it turned viral, and we ended up consuming about 10 to 12% of the entire transaction volume of Ethereum, and at peak times up to 25%. So essentially, that showed pretty drastically the limitation of Ethereum. And I mean, back then, it's actually not surprising, right? Ethereum was, or Ethereum is a blockchain which is largely focused on transferring tokens, with some support of computation, while CryptoKitties, on the other hand, has some aspects of tokens in it, or NFTs in it, but it also pretty heavily relies on computation for the breeding. So it has like a gene matching algorithm in it, and so we realized that while CryptoKitties for its time was very successful in the crypto, space, that if we ever attempted to launch a blockchain-based experience where we potentially could have millions of users or hundreds of millions of users, that the current platforms back then, the established platforms, wouldn't support it, right? So we started looking into what would we like to build as a follow-up experience to CryptoKitties on, right? And so we were looking at various criteria, and we looked around. We read about 100 white papers, talked to probably something like 20 different blockchain initiatives, startups, companies, and for each of them, we're like, yeah, okay, that's it's a compelling concept, but still, for each of them, we also had doubts in terms of how well they would scale, and also how well they would support a single dApp, which has a large volume of computation and transactions flowing through the dApp, right? Because what we realized with CryptoKitties is that while it's important to support a lot of transactions, it's also important that all those transactions can interact with a single dApp without much overhead. So I mean, out of the experience of developing CryptoKitties, we were mainly looking for a few aspects. So one aspect was that we wanted deterministic finality, because the reorgs of Ethereum are kind of fairly hard to deal with on an application aspect. The other thing we were looking for was composability. So the ability that dApps or extension of dApps could easily talk to each other, which becomes a little bit more difficult if you're thinking about a sharded blockchain, right? So what we were looking for was a blockchain which had very large processing capacity in a single shard, and could support a large audience, and while still maintaining strong asset guarantees. And so the more we thought about, we started thinking about what we were looking for, and also how we would potentially solve such a solution, the deeper we got into kind of just playing around with the idea of how could a high throughput blockchain look like, which does not primarily rely on sharding for scaling. And so, and that was kind of the start of Flow as its own blockchain.
Awesome, thank you. Yeah, so just want to make sure I understand what you're saying. So a lot of these other blockchains employ sharding, or maybe like some other kind of sharding-ish. Like Cosmos is just, let's just make a single blockchain. Let's just make a blockchain for every single application, which has its own problems. But we can, but maybe let's first, because there was a lot there, and I just want to like revisit a few of those points to really talk about Flow. So the first thing you emphasized was like complicated computations, right? And I think this is pretty interesting, because a lot of these scalability efforts are like, how many transactions can we get through the system, right? That's like throughput. But complicated computation, would you say, is, I think it's something that a lot of protocols are kind of pushing to layer 2. You guys are putting it in layer 1, and that is, and do you think that's like related to do you think that's related to scalability? Do you think that's related to the composability that you mentioned, where if you're putting that into the base, like the blockchain, quote unquote blockchain itself, does that how does that generally make it simpler for applications that are written to talk to each other?
That's a very good question. Thank you. So essentially, if you're looking at a general or our general compute infrastructure, right, it's usually composed of microservices which talk to each other, right? And what you want is those microservices to talk to each other without much, barrier and overhead. And specifically, what you want is that those microservices can augment each other, right? So you have different microservices and they all build up a larger application. And for that application to be responsive for users, for that application to be responsive for users, the interaction between the different, components needs to be fairly low latency. And what sharding implicitly actually introduces is the need to cross-communicate between shards, lock resources on one shard, then do something with that resource on the other shard, see whether the transactions and computations on the other shard have succeeded, and then accordingly update the first shard. So you have kind of cross-communication there. You can think about it as similar to multi-threading. And what we just generally learned, from ease of development is that the more capacity your single instance provides you, the more capacity your CPU core has, the less you have to deal with cross-process communication. And that pretty much translates to blockchains, right? The more capacity your single shard has, the less the developer has to deal with cross-shard communication, locking, and asynchronous computation. And and so since we think that providing compelling experiences to end users will require some computation and will require dApps to interact with low latency, we think that is very important to have a blockchain which can process a lot of computation in a single shard. I mean, that's not to say that Flow doesn't support sharding. I think essentially or eventually we might want to shard it just, to kind of create separation of concerns. You can think of a government blockchain. They probably don't want that.
Or maybe someone makes some kind of awesome dApp that millions of people use. Then sure, give it its own shard, right? Totally. So and I just want to highlight something that Dan Truk said in the chat. Sorry if I'm not pronouncing your name correctly, but I think transactions. I definitely agree that this is an important distinction to make. That when we're talking about transactions per second, most people are thinking about financial transactions. And I think what's interesting about trying to build games on a blockchain is you're trying to run. Well, I mean, in CryptoKitties cases, trying to run gene selection, or that kind of a modeling process of trying to breed kitties, which is something that's a lot more complex. Say moving a token around. Right. So I think this is a very good point. Cool. So now that we touched a little bit about why Flow exists, maybe we can talk a little bit about how Flow is able to do everything that it does in a single shard. And at the same time, and then after that, I think we'll do some Q&A on the technical side, and then we can move a little bit on to talk a little bit more about product. Because I think there's some interesting things happening in Flow. You have some big names you're working with that we definitely want to talk to, or that we definitely want to learn more about. So yeah, so first, so I guess for some background, in case people aren't familiar with the Flow scalability idea, the general idea, and correct me if I'm wrong, is to separate consensus from compute, where you can actually, all consensus really needs to do is order the transactions, right? So all these transactions are saying, run this piece of code, move this token around, or whatever. And all that matters is, ordering those transactions, having a strict ordering. And once that's done, you can hand it off to a separate computation stage. And this gives you what's in effect pipelining, in which basically you're able to do the computation and the consensus at the same time. And so it's kind of like how in a sharded blockchain, you're processing transactions in parallel, where here you're getting parallelism too, but it's more like you're splitting it into different stages. Kind of like the common analogy that, for people who might not be familiar with pipelining, is doing your laundry, right? So if you've ever done your laundry, just think about when you do your laundry, you don't put your clothes into the washer, then take them out of the washer and put them into the dryer, and then take them out of the dryer and fold them, and then take your next load and then put it into the washer, right? You don't do that. You put your first load into the washer, take it out of the washer and put it in the dryer. You take the second load and then put it into the washer. And so you're doing multiple things at once. And this is like the general concept of how Flow achieves scalability. And do you think, but there's a lot more to it than that. And I want to know if you can tell us a little bit more about how Flow is able to, because I think this is only, if you're doing consensus and execution at the same time, that's only two-way parallelism. But in order to do one shard, I think you'll need a lot more than that. So if you could tell us a little bit more how that happens.
Thank you, Sebastian. That was actually a great analogy with the laundry. So, the idea actually goes back prior to Flow, right? Because distributed databases, they already do that. They have a global transaction log, which is populated by usually a small consensus committee. And then you have the replicas, which just apply that pre-order transaction log. And so the idea was similarly to apply that to blockchains, because so in blockchains, you generally have a subjective and an objective component. The subjective component is, I have a bunch of people who want to do stuff. Which person gets to run their transaction at which point, right? But once that's fixed, and you say, okay, this is my transaction log, and here's the starting state. Please apply the transactions one by one to that starting state. The output is kind of deterministic, and so the idea here is, specifically in Flow, to separate the subjective part, the ordering of transaction, from the objective part, is computing it. And that also gives rise to a completely new domain of optimizing the, the performance requirements of the individual actors. So in a single, let's call that single cycle blockchain, right, where all nodes do the same thing, and in the end, you have a person which proposes, or a participant which proposes a block, and in the end, everyone needs to, or people need to agree that this is a valid block, and if they agree, they can build on top of it. So if you now take that into into a pipelined world, you say, well, okay, so the first thing is that you have a node which receives transactions, and that's what we call the collector, right? So the collector receives the transactions, and it actually batches them in something which we call collections. So just think about it as a small batch of transactions, and then those batches, those collections, go to the consensus nodes, which order them and determine the execution order of those collections. And then the order of the collections is recorded in blocks, and then the blocks go to the execution nodes, which process the transactions in the order they are listed in the collections, and following the order of the collections how they're listed in the block. So at that point, you get a result, right? But as it's common in blockchains, you usually don't trust the individual actors, right? So now you have execution nodes which essentially suggest results. And you have to account for the possibility that some of those results might be wrong. And so, and then you have verification nodes, which consume those results and check certain subsegments of them. And only after, and if they find the computation segments they check, if they find those to be valid, then they send approval back to the consensus nodes. The consensus nodes collect those approvals, and in the end will kind of commit a result into the blockchain once it has been approved by enough once it has been approved by enough verification nodes. So the important point here is that each of those nodes has a distinct task, right? Which in a single cycle blockchain, you would combine them all into one node. Every node would have to do the same full set of tasks. Here we have dedicated nodes which each do their own special thing. I like to compare that to like CPU pipelining, you know, where you have instruction prefetching, then you have the instruction unpacking into multiple like smaller instructions, and then you execute those instructions, potentially even with speculative instruction execution.
Yeah, absolutely.
And
yeah.
Sorry, let me just quickly point out one important detail here. And so the important part with all our different node types is that each node type has their own requirements, right? So for instance, we have execution nodes where we conceivably can require that each of those individual execution nodes brings a terabyte of RAM. Right? If you would apply that to a like general purpose single cycle blockchain, it's very unlikely that node operators will be okay, I can spin up a node with a terabyte of RAM. But since Flow only requires very few execution nodes, but very powerful ones, you know, while we require less powerful consensus nodes, but more, you know, we are able to kind of shift the local trade-off depending on the task at hand.
Awesome. Yeah. Wow. So there's actually a lot there. So I think I just want to walk through it because try to unpack it, because I think that was a lot. So first, I think so the one difference between the kind of simple version that I said and the full version that you gave, which was like really awesome, and I'm probably gonna have to come back and watch it and like pick apart basically every sentence you said, and then probably really do a more in-depth reading of the white papers. This actually sounds really cool. So there's actually not just two stages, there's more stages, right? Because you have the collector nodes. So at the same time, so the consensus nodes don't actually need to collect the transactions from apps. So that's pretty cool. The other thing is that, so that's like so that's like another optimization where you're adding another stage to the pipeline. You have another pipeline, or you have another optimization where you're actually ordering collections of transactions. And not how big is a collection usually?
So we envision that for the mature system, a collection will have up to 1,000 transactions. So it has various limits, you know, on the pure number of transactions, but also on the maximum of amount of gas, if you want to call it like that, which can be included in a transaction. So each transaction a collection. So each transaction has to say, I'm willing to pay for this and this amount of computation, and then the total amount of computation in a collection can't exceed a certain value. But in essence, if you have something like simple transactions, like just moving NFTs around, it will easily be able to accommodate, a collection will easily be able to accommodate up to 1,000 transactions.
Sure. Okay. Are the collection nodes generally trusted? Or they have their own mechanism for not?
Yes. So none of the nodes in our system is trusted.
Okay, yeah.
Which is very important, right? Because we want to design a decentralized blockchain where you can't really trust actors.
Cool. So yeah. So that complexity aside, so it's almost like these collections are eventually going to become like little blocks that go into actual blocks.
Exactly.
So it's almost like and then consensus nodes just within a block have to agree on the order of those blocks, and then the order of transactions within a collection is just whatever, or
yeah. So collector nodes generally just pack the transactions into collections. So each the collectors are grouped into small clusters. You know, you ask the question, what if a collector is dishonest, right? And so that requires that we have the collectors checking each other's work, right? So we separate the collectors or partition the collectors into clusters. So if you think about having 1,000 collectors, we could separate them into 10 clusters. Each cluster is 100 collectors big, and those clusters internally form their collections all together.
Okay.
You know, so even if a few collectors or a larger fraction of the collectors is dishonest, you know, there is still like a first level of security, which is the Byzantine fault tolerance of the consensus algorithm they're running. And then there's a second level of security, which even if the entire cluster is malicious or is dominated by a malicious consortium, that when the execution nodes eventually will try to execute that collection, they're like, this is not faulty, right?
Absolutely.
And then the entire cluster will get slashed.
Wow, so it's almost like there's it's almost like they have their own do they have their own consensus or this is just like so it's almost like we're making a block and we get consensus on that block, and then we hand it to the next stage, and then we order all those blocks into like the big block.
Mm-hmm.
Wow, that's pretty cool. So and we're actually talking at a higher level here, right? Because we haven't actually talked about consensus like BFT protocols at all. Now, as far as I'm familiar, you guys use do you guys use hot stuff consensus?
Mm-hmm. Yeah, we essentially use a small derivative of hot stuff.
Yeah, a small but in theory, if I recall, in your white paper, it said that it should work for anything with like deterministic finality, or I guess for in a non-technical point, that means that the blockchain has a sense where there is a time when the block is totally committed to the chain. It's not like because like on the Bitcoin blockchain or the Ethereum blockchain, that might not be the case, you know, because like because which chain, like if there's a fork, which chain is the correct one is defined. You need to have all of that, you know, fork choice rule, where with a deterministic finality thing, you know, at a certain point that the block will be like, this is a block.
Correct. Yes.
Awesome.
So there's a deterministic criterion where if you follow the chain, you just look at the blocks, you're like, okay, according to my criterion, this block is now finalized, and you can be sure that then that block will never kind of be abandoned later, unless you have like a large fraction of Byzantine actors, malicious actors in the system.
Yeah, absolutely. Yes, Dan brought up a good point. Yes, Libra. If I also, I think I do. Yeah, Libra does use at least a variant of hot stuff. Yeah, I think a lot of blockchain protocols are like have adapted hot stuff, because it's a pretty interesting protocol, but that's not exactly what we're talking about here. So cool. So this scalability aspects of this is really cool, and we can. There's actually a lot. I think there's a lot to say about the interesting problems that come up, and how do you keep the system secure? How do you keep all of these nodes honest? And I think, would you say a lot of it actually falls on the verifiers?
So that is actually the main complexity. So if you start thinking about a pipeline system, right, you have to ask at each step or each output of a pipeline component to ask the question, well, what happens if that pipeline component is broken? How will I catch that, right? How can I attribute the error to actually the actors which introduced the error and not slash everyone? And how can I recover from the error, right? And so those are the three criteria which are underlying design principles for Flow. So the attributability of errors and honest work, the punishability of errors, and the recoverability of errors. And so for execution, the responsibility to find errors is particularly with the verification nodes. But there, you know, in each stage, the output is consumed by one particular other group of nodes, and those other group of nodes then have the ability to, I guess, challenge the previous group who produced their input, challenge them of dishonest behavior or protocol violations, right? So if the collectors produce a broken collection, the execution nodes will catch that because they are the ones who are consuming the collections or going through them in detail. Also, the consensus nodes might catch some errors in the from the collectors. For instance, if they don't sign their collection properly, right? So like simple errors, like signature errors that will already be caught by the consensus nodes. Then, if the execution nodes make errors, those are caught by the verification nodes. If the verification nodes just approve a broken computation, the verification nodes can challenge each other, or the consensus nodes might uncover that. So, and in each of those points, you need actually a mathematical proof saying that the probability of an error slipping through is sufficiently small. So like 1 in a billion or something.
Yeah, totally. Yeah, so that's actually really cool. And so, so when the verifiers are like verifying these computations, I think that so the verifier is just like, running the computation, and then they say, yeah, this checks out. Is that generally the kind of thing that they're doing? Cool. So, yeah, and I think that arises from the neat subjective objective kind of dichotomy you mentioned before, because the whole subjectivity is kind of like what consensus does, right? There's multiple versions of the truth, which is what happened and when. And but once you know what happened, like if a transaction says 2 + 2 says 2 + 2, and the execution node says 5, well then that's obviously wrong. And so all a verifier has to do is sum 2 + 2, and know what that is. So yeah, that's pretty cool. So I want to take a little bit to go through some of the technical questions that we have, and then we can really talk a little bit more on the product side of things. So first question, so is the collector nodes like Bitcoin's mempool? Yeah, so as far as I understand, it's performing the same role, kind of, but in separate nodes.
Yes. So on a very high level, you can think about it as like a mempool, but it has very important different characteristics, right? So the collectors, as I said earlier, they're partitioned into smaller groups. So it's like we are maintaining several independent mempools at the same time, right? So similarly, as you have like several instruction prefetching units for your CPU cores. And so each of those collectors is like a mini mempool. Then the consensus nodes who are processing the collections, they essentially also have a mempool, right? But in their mempool, they don't keep transactions, they actually keep the collections, So they say first comes collection A and then comes collection B. So I think it's important that we don't quite think about it as a mempool, specifically since it's distributed, it's hard to query and see what's in the mempool. So that kind of makes important operational differences.
Cool. Yeah, but it's definitely, just to reiterate, it's performing the same, it has a similar purpose, but has very different characteristics that I think are advantageous in the context of Flow. Cool. Okay, so the next question we have is, okay, so let's first, so would you elaborate to the non-technical listener on multi-threading, either as an analogy or regarding how it's directly relevant to blockchain computation? So I think to answer this question, I think we don't really have to talk about multi-threading as much as just doing several things at once. That's all we have to think about, right? So if the system, so in a traditional blockchain, right, all the nodes do everything together. So you could think of this as if you're doing a group project, right? And let's say you have like 5 people in your group and you have to do like a lot of work, right? One way you could do it is have everyone sit down at a table together and have everyone do every problem together, right? And sure, you might not make mistakes that way, but it's slow because everyone does there's a lot of work duplicated, right? Where in theory, what you could do is split the work 5 ways, and now you do the work 5 times faster, right? So that's this concept of, if you could do things in parallel at the same time, you're able to do more work and you're also able to do more faster, right? And so no matter what it is that you're trying to do, you want to the whole idea behind parallelism is try to do many things at once instead of just doing one thing at once. Because that's the whole idea, is be able to push more computation through the system. And this kind of pipelining here, and just remember the laundry analogy. That's probably like the best way to understand pipelining, is just think about when you do your laundry, where, you know, if you have multiple loads of laundry, you put the laundry through the washer, or you put one load into the washer, and then you take that load out of the washer into the dryer and put the second load into the washer, and then you have both the washer and the dryer running at the same time. And then potentially you could take it out of the dryer, fold it, or you could take it out of the dryer, then take the second load, put it into the dryer, take the third load, put it into the washer, and then fold your first load, and all of a sudden you're doing 3 things at once. And that's the concept that Flow really operates on. So I think that's like hopefully that was like somewhat sufficient.
You're very good at analogy. Thank you. That's great.
Yeah, of course. Yeah, I can credit that to the I actually can't remember what class that was, but whatever the class I took that introduced pipelining, they introduced it as laundry, and I think that's a very good way to introduce it. Anyway, so yeah, so next question we have that is upvoted is, a current trend in layer 1 blockchain innovation is optimizing for 1 or 2 of many different parameters. And for example, the trilemma. Do you see, or the blockchain trilemma, which, in case you're unfamiliar, is this kind of, you know, like, if there's like a triangle that Vitalik Buterin kind of, or it's also called Zamfir's triangle, but that you can have high throughput, you can have decentralization, and you can have security, and you get to choose 2. But the question here is, do you see maximalism towards a specific parameter, or do you see that that flow is particularly optimized for many purposes? Sorry, do I understand that that question correctly? Oh, okay, so he says, oh, so I see what he's saying. So Adam is asking, do you think in the long run it's better to have one blockchain for everything, or that optimizes for in a general sense, or do you think many blockchains that are optimized for their particular use cases?
That's kind of predicting the future. Those questions are always very hard.
Yeah, absolutely. I mean,
I can share a little bit of a personal opinion on that. So I think in the end, it will be a mix of both, right? If you just extrapolate what we see nowadays in cloud infrastructure, right? You have large general purpose infrastructures. And then if you need like peak performance for one particular task and only that task, and you can completely isolate the task, then it makes sense to think about a special purpose platform. And I think the same will be for blockchains, right? So I can totally see that, for instance, some companies might want to do a special purpose blockchain because they believe or they know that they have one particular use case, they can hyper optimize their blockchain for that use case, and then and just kind of run it between their companies. But I also think that there's high demand for a general purpose platform which supports like an operating system, right? Which supports general computation, so that if you're starting with something and you don't quite know yet if you are in one of those niche application areas, you know, that you have a go-to platform, you know, you can try it out like AWS or GCP, right? If you just want to try out things, you go to the general purpose platform, try it out there, and in most cases, you will actually stay there because that's where the users are. I mean, let's not forget that blockchains are essentially also an ecosystem, right? And within an ecosystem, you want to reach users. So if you're developing a game or a dApp, you know, which is for end users, you want to go to a blockchain where there are a lot of users, and where the users have a good ecosystem. It's easy for the users to interact with the blockchain. It's there are other engineers who are potentially building on top of your dApp, which like composability, making it better, making it more awesome. And so that's the reason why I think there's a strong need for a general purpose blockchain.
Cool. Yeah, absolutely. And Dan definitely hits the nail on the head here that the trilemma I think it's good as a way, as one particular lens to look at a system. But I definitely think looking at everything in terms of the trilemma is just, it's just buzzwordy. Right.
Yeah. May I comment quickly on that trilemma? That's actually a very interesting point, which we also spent quite a lot of time thinking about during our initial research phase. So to just rephrase that dilemma in my own words, essentially, as you said, it's a triangle, right? And the top point of the triangle is you have a small but responsive system, right? And so now but you want to make the system bigger. Right? Because small means it's not really decentralized. If you only can admit 10 actors, then it's very easy to kind of centralize those actors or think that those actors might collaborate in some way. So you want to make it bigger. And now you have two options. Either you make it bigger and then you require all the nodes to exchange a lot more data, because suddenly a node doesn't need to talk to 9 other nodes, it needs maybe to talk to 900 other nodes, right? So that will require more resources. So you can either make it bigger at the cost of more resources, or you can say you make it bigger and don't invest more resources, but then your system will be slower because it has kind of, per participant, like if I'm communicating with 900 people, it takes me a lot longer to talk to all of them. And so that's essentially the trilemma. And I think the important part with Flow is that Flow looks at each of those individual processing steps and asks, what is the optimal trade-off for this particular processing step? And so, for instance, for execution, we say, no, it's totally fine to only have 8 execution nodes. They're thoroughly checked by the verifiers. Everyone can run a verifier, so there is no problem. Even if those execution nodes are all colluding, they still don't get a wrong result in. So there we are at the tip of the triangle and say we have a small but responsive system. For the consensus and verification nodes, we want a larger system or a larger group of nodes, but we specifically give them a task which doesn't require much work so that they actually can be fast, even in a big group. So I think it's very important to kind of not see that trilemma as a global trilemma, but actually as a task-specific dilemma.
Cool. Yeah. Yeah, that's definitely have to spend some time thinking about that aspect of things. It's almost like Flow is like how you do things. Or anyways, I think we do want to have some time to talk a little bit about some product and then maybe answer some more product questions. So first, the first thing I want to mention for the people here who might not be familiar, so Flow actually has partnerships with both the NBA and UFC. So with the NBA, we're supposed to be seeing some collectibles. Can you say anything about them? Right, like what is in planned, what's in store?
Yeah. So let me start with a little warning. I'm fairly deep into the protocol aspect of Flow, but Flow is a big project, and it's kind of part of a larger initiative, not only to bring or to develop a blockchain, but also develop an ecosystem around it. And I want to be very careful in terms of what information I volunteer, that I don't tell anything wrong and don't tell you any outdated information. So what I can tell you about our partnerships is that we currently have that we have projects with the NBA, which is already, NBA Top Shot, that's already live. You can essentially buy moments, like if you're an enthusiastic basketball player and you really want to collect all the biggest moments of your favorite basketball players, you can collect them as little, as moments, video snippets, which essentially you will own, right? So it's that the NBA kind of gives you the ability to buy those, to collect those, right? Similar with UFC, we also have partnerships with Dr. Seuss, and partnerships with Ubisoft, Animoker, Warner Bros. Music Group, or Warner Music Group, and so those are all they're all kind of tailored towards. Or at least the first few are tailored towards NFT, giving people the ability to collect, giving the ability to dive into something fun and approachable, right? But I mean, my hope is that essentially this ecosystem will diversify, right? We're now seeing the first step of people wanting, or people interacting with blockchain and understanding that it's not only cryptocurrencies, but that you can have personalized experiences. And personalized experiences necessarily mean NFTs in the beginning, right? But later, it might not only be an NFT by itself as something which has unique variables, but also maybe something which has unique behavior. You already see that kind of starting with CryptoKitties, right? Where you don't only collect the picture, but that the kitties could have different abilities, like different algorithmic components. And that's kind of where I see the broader development of the system.
Cool. Yeah. So you're saying, like, maybe in the future there might be a game where you can collect a certain NBA player and then you can play games with them. It's cool. That's awesome. So what do you think, like, if there's a specific attribute of Flow that makes it uniquely good at getting these more, I don't want to say bigger name, but like these are things that the general non-crypto native person will know. But if you look at other blockchain ecosystems that are kind of starting, even ones that are like a lot more mature than Flow, most of their partners are like people who are very crypto, like very crypto companies. And here and Flow is kind of like, hey, we have a partnership with a giant basketball association and UFC and Dr. Seuss, and we like all of these things that people act that the average person who has no idea what crypto is will know and understand. And I think this is like really important when it comes to mass adoption. So do you think, like, do you see this as like part of the technical aspect of the Flow blockchain, or do you think it's more that it came out of Dapper Labs, so it's someone who knows how to build a product that people will use?
That is a very interesting question. I would almost encourage you to talk to one of our product people for that, But
sure.
I can share a little bit of my own thinking about that. So I mean, similar as with an operating system, it's a platform, and the platform is there to be used, right? And and the specific goal of Flow as a blockchain and NBA is to not develop a niche product, but actually develop something which reaches the end user, non-crypto enthusiasts, or people who are not crypto enthusiasts, And blockchain specifically blockchain is a fairly, I would say, technically challenging domain, right? Where people rightly so feel a certain resistance to really diving into it, and so what better way is there than actually offering people like kind of relatable experiences which are similar to what they know out of the real world, to get them excited, about blockchains, so that they have a starting point to familiarize themselves more with the technology, have a starting point to familiarize them more with also the abilities blockchain give to the end users, in terms of decentralization and frictionless markets. I mean, we see that all over our current world, that certain things you bought, but essentially you rely on the seller to keep that thing for you. Like think about a skin in a shooter game, right? You buy that, but if the gaming company decides to no longer support that, it kind of, you lose your ownership.
Sorry, I don't mean to interrupt. I just want to get to some other things that people are asking. So I think there's one other thing that I think we want to talk about is, how does the average crypto-friendly student get involved? Like, what if I'm like if I'm a CS or maybe business student at a university with a blockchain club, what's the best way for me to start building stuff or getting involved with Flow? Like, does Flow have a bounty program or a hackathon? Are you hiring people? Yeah, can you tell us a little bit about that?
Yes, yes, and yes. So, I mean, of course, the first thing you probably want to do is check out our website. It's onflow.org. You can join our Discord channels. You can follow us on Twitter. But we also like specifically try to support community projects. Of course, first with technical support, but we run an open world builders program where you can learn about how Flow works, and kind of make your first experiences. It's similar to like a hackathon, slash, a little bit of like a tutorial. And if you want to contribute, of course, Flow has now been open sourced. The main protocol has been open sourced. So if you want to contribute, we're also welcoming like community contributions, and yeah.
Awesome. Yeah. Cool. So what kind of jobs? Actually, no, I'm sure we can go and look at those.
Yeah, check out our website.
Absolutely. Cool. Yeah, and also another thing I wanted to say, thank you, Nick, for also pointing this out, because I think this is a good way to say a problem with a lot of blockchain protocols today. But I think, cool. Is there a secondary marketplace for NBA Top Shot? I don't know. I feel like that's a pretty specific question.
Yeah, I mean, in the end, you will be able to, the NBA Top Shots moments, they are, in essence, they are NFTs, so you will be able to trade them through convention or through the basic means of the Flow blockchain, right? But I mean, of course, there is, for non-crypto enthusiasts, there's also a higher level abstraction above where, you can trade them through the websites sitting on top.
Awesome. Yeah, totally. Okay, any other interesting questions? Questions that are good. Cool. Does anyone else have any other questions? You can feel free to drop them in the chat. There are some other questions in the Q&A there. I think we touched on most of them. Is there anything else anyone wants to ask Alex while he's here?
So the bounty program, we will soon be launching bounty programs, yes.
Awesome. Why go from a PhD in quantum theory to blockchain? I'm sure that's a long story.
Well, I like math problems. That's the short answer.
Yeah, of course. You go where the interesting. If you like problems, you go where the interesting problems are, and well, blockchain's where the interesting a lot of the interesting problems are right now.
And let me highlight. I mean, one of the biggest aspects for me, why I'm so enthusiastic about the project is actually the team. We have an incredible amount of exceptionally talented people, and so even for somebody who is not a native crypto enthusiast, it's still great to work with all our team members every day.
Cool. Yeah. Someone asks if you would like to, if you can comment on the upcoming token sale.
No, probably not.
Okay.
I think I'm not.
Totally. Yeah. Cool. Well, I think we're almost out of time. So thank you very much for spending your time here today. I definitely learned a lot. I'm also, I think, much more interested in the Flow protocol, and I hope other people are. This is a really awesome project, and they're doing something that a lot of other projects aren't. And I think it's going to be awesome to see what gets built, how it ends up shaping.
Oh, great. Yeah, that was awesome. Oh, sorry, Alex. Go ahead. Last comment.
I was just wanting to thank Sebastian for having me. That was a great chat.
thank you guys both for doing this. We really appreciate it. I think we had some great questions, some great answers from you, Alex, some great analogies from you, Sebastian. Thank you for the laundry comparison. That was great. And just to remind everybody, we're going to have a networking session. So if you want to stick around and meet new people, you can hop on and off different virtual tables and chat with other people. And just to remind you guys, next week we're going to host Catherine Cooley from Binance US and Vanessa Grelette from Consensus to talk about path to mass adoption. So stay tuned, check our accounts on Twitter, LinkedIn, follow Flow on Twitter as well. And yeah, that's about it. Again, Alex, Sebastian, thank you very much, both of you guys. And I will see you all in the networking portion.